Here are some more examples for the ambiguous law of sines. Basically, what you're going to have to do now is draw a picture each time and figure out if we're going to use law of sines regular, law of cosines, or the ambiguous law of sines. And it'll be important that you show your steps. And the big thing, sorry about this, my little text box is being very uncooperative. It might have senioritis. We'll see. Okay, so draw a picture. Label it A, B, C. Label your parts. Angle A is 64. Little a, 17. Little b, 16. And we don't know little c. So this is definitely an SSA triangle, which means we're going to have to test it. So original law of sines, sine of 64 over 17 equals sine of b all over 16. Sine of b equals 16 sine 64 all over 17. And if you throw that in your calculator, it's going to be approximately 60.0. So we know now that we have one solution. Now we're going to subtract from 180. And that's going to give me approximately 120. Now our big thing is we have to check how many triangles there are. So we're going to take our 120, add it to the original angle 64, and that's going to come up 184, which is bigger than 180. So there is only one triangle. And then we will solve it using the law of sines. This text box and I are fighting, and it's not going very well. There we go. Okay, so now come back, start with, we found the measure of angle B, and so now we're ready to find the missing angle C. Little geometry, 180 minus, and we're going to take 60 plus our original 64, and that's going to give us 56. And so angle C is 56. Now we need to find the missing side C. So known fact, sine 64 over 17. Take the sine of angle that we just found, 56 over C, and cross multiplying 17 sine 56 over 64. Put that in our calculator, and C then is 15.7, and that triangle is solved. Hopefully you are seeing some patterns as to what we're doing. Okay, now next one, draw a picture. So A, B, C. Angle B is 57. Oops, I'm one example ahead of myself. Let's try this again. So drawing that picture still, A, B, C. A is 32, B is 17, C is 11. This is an SAS. So this means we're going to use law of cosines. So to start, we would say that B squared, that's the side that's missing, 11 squared plus 17 squared minus 2 times 11 times 17 cosine 32. type everything over here on the right, and then press enter and do a caret 0.5 for your square root. That's the fastest. And that's 9.6, and that's our missing side. Then we are going to use the law of sines and find the smallest angle first, which would be C. So sine 32 over 9.6, and then sine of C over 11, sine C, 11 sine 32 over 9.6. Remember to take an inverse, looking for an angle, 37.4. So there's angle C. Now we just have to find the missing angle measure. So angle B is going to be 180 minus 32 plus 37.4, and that's approximately 110.6, and then that solves that particular triangle. Now for this last one, again, you should be at the point where you can take some steps by yourself. And so maybe mute this video, draw the picture, maybe try a little bit on your own to be sure that you're understanding kind of what's going on. So 13 and 18. So now side C is missing. This is an SSA, so we're going to have to check it. So remember, sine 57 over 18 equals sine of A over 13, and the sine of A is equal to 13 sine 57 all over 18. So the value of angle A, taking that inverse again, is 37.3. So that's one solution for sure. Now let's see what happens. So 180 minus 37.3, that's approximately 142.7. And if I take 142.7 plus 52, or 57, sorry, that's bigger than 180, so there's only one triangle. And then you would continue to solve that how we did before. So then that means angle C would be 180 minus 37.3 plus 57, and that C is approximately 85.7. Wish I was teaching you guys right now here. Okay, then sine of 57 over 18 equals sine 85.7 over C, and then using the method cross multiplying, I'm not going to show that exact step right there, that last value for C is 21.4. So the biggest point of emphasis is to draw a picture every time to solidify what law that you would like to use.